Hello friends, it's Monaco here. We're going to hit up atomic structure and element notation for your fourth video lecture. We're going to cover protons, neutrons, and electrons, what their properties and locations are, and how you can find these quantities from element notation. You'll also have a Google Classroom assignment to follow this up. So here we go. First thing you got to know is about the basic structure of the atom and the subatomic particles. So, A, protons. You can see it's pointing to the positive charged things. So they are always inside the nucleus. They have a mass of 1 atomic mass unit and a positive charge. That's just the definition of a proton. Know it, love it, tattoo it on you. Next thing you got to know is neutrons. These dudes also live inside the nucleus. They also have a mass of 1 atomic mass unit, but they have no charge. Neutron. Think about the root word, neutral. Neutral means no charge, so that's how we got the name. In this particular picture, B is pointing to the white spheres inside the nucleus. Now, C, the nucleus itself. The picture is pointing to the area that contains both the protons and the neutrons. Okay. The nucleus itself isn't a shell that has protons and neutrons inside it. In this particular area and picture, it's just circling the region where the protons and neutrons are found. It's that dense core of the atom that Rutherford found out has a positive charge, and it holds the nucleons. Nucleons being a key word that means things that live in the nucleus. So nucleons, nucleus, center of the atom. Now an orbital. This is synonymous with the energy levels, okay? These are where the electrons reside. Letter D is pointing there. You notice there's multiple orbitals, okay? And as the elements get more complex, we will add more orbitals when we have to add more electrons. And the last thing, E, for electrons, they have a mass of 1 over 1,836 AMUs. So that basically has no mass and a negative charge, which J.J. Thomson and his cathode ray experiment proved. Okay, so that's your basic structure of the atom. No mass, negative charge for the electrons. So memorize this. Take a mental photograph in addition to your notes and just burn it in there. Very, very important. The subatomic particles, let's summarize them where they belong. Proton has a charge by convention of +1. A mass of 1 atomic mass unit. A location in the nucleus. And there's a couple different symbols that we use to show it. P is very rare. 1p1 is very rare too. The symbol usually used for protons is plus sign. Most of the time in my class, I'll just draw a plus sign inside of a circle. Proton. How to calculate protons? Well, you got to look at the atomic number off the periodic table. You literally just read it off. Find the atomic number using the key on the periodic table. Find the element you're after. Boom, that's your number of protons. Neutrons. They have a charge of 0 because they're neutral. They also have a mass of 1 atomic mass unit, like the proton. And like the proton, they live in the nucleus. Now, the symbol for neutron is used a little bit more often. 1n0. 1 for atomic mass, n for the neutron, 0 for the charge. And to figure out the number of neutrons in an atom, you look at the periodic table, you take the atomic mass number, which is written there in the key, and you subtract the atomic number from it, which is also easily found when looking at the key. Electrons. Well, by convention, J.J. Thomson proved and said that electrons have a charge of -1. And many years later, we found out how much they weighed. It's very, very tiny. So it's 1/1836th of the size of a proton or neutron. So we call it negligible. We usually don't count it. These are located in the orbitals or energy levels outside the nucleus. And the symbol, which is very commonly used in my class, is E with a negative charge next to it. or just E. I like to put E with a negative up in the corner because that's an electron. To figure out the number of electrons in an atom, it's equal to the protons if the atom is neutral. And that's, I guess, what the definition of an atom is that it is neutral. The protons and electrons are in balance. But if you have an ionic charge, that equals the protons minus electrons. So sometimes if your protons and electrons are out of balance, you'll have to do a little figuring out to see how many electrons are there. And there again, charge is equal to 0 for atoms. So you can figure out very easily the number of electrons in an atom. To find the electrons in an ion just requires a little bit more thought. Let's see here. We got these to go away. And nucleons and neutral atoms. So nucleons are the subatomic particles that are in the nucleus. So by definition, the protons and neutrons. And a neutral atom has a net overall charge of 0. Therefore, the number of protons equals the number of electrons. I'm starting to feel like I'm repeating myself a lot when it comes to those ones, but which, hint, hint, wink, wink, nudge, nudge, nod, nod, very important to memorize and know. So, interpreting the key on the periodic table. In the top left corner, we have the atomic mass. That's an average mass of all the isotopes of an element, and we will do that in our next lecture, I believe, what isotopes are and how you find out that average mass. Atomic number is the number of protons in every atom of that element. If I changed this carbon atom from having 6 protons to having 5 protons, it would no longer be carbon, and it would be a different element. And we can't do that. It's called a transmutation. Electron configuration is the number of electrons in each energy level and the numbers to get to the total number of electrons. So 2-4 means there's 2 electrons on the inside ring and 4 on the outside ring for a total of 6, which for a neutral atom of carbon is exactly how many you need. The element symbol, this is the easiest thing to recognize, and it's the single or 2-letter code that we use to identify the element when we're talking about it. And the last thing in the periodic table square is the oxidation numbers. These are the possible charges of an atom that an ion of an element of that atom can have. Okay, so what this means is that carbon is able to form a -4 ion, a +2 ion, or a +4 ion. So that's what oxidation numbers mean. Okay, we're going to get into that more later on in the year. So, basic definitions. Atomic mass is the average mass of all the naturally occurring isotopes of an element. We'll get into that in more detail in the next lecture. Atomic number. This is the number of protons in every atom of the element. Gold is gold, and it always has 79 protons. If it doesn't have 79 protons, it's not gold, it's a different element. The electron configuration is the number of electrons in each orbital or energy level, and you got to add the numbers up to get the total number of electrons. So you can count to figure out electrons usually. Selected oxidation states, the possible charges of an ion that an element can have, because there's only a few options for each. And sometimes only one. And the symbol, it's the letters used to identify an element. The first letter is always capitalized. The second letter is always lowercase. 3 notations. The thing that provides most information is the standard notation. It tells you the symbol with both the mass and atomic number. So you can figure out protons, neutrons, and electrons from this. Simplified notation. Well, you write the whole word of the name of the element out and follow it with a dash and then the atomic mass. You can find out the atomic mass and the identity, but it's not as easy to find out the protons, neutrons, and electrons. Okay, you got to do a little digging to find that out. The condensed formula, this only tells you the name and mass, and again, you got to do a little digging to find out the protons, neutrons, and electron numbers. The condensed formula only gives you the symbol of the element and the mass. So again, it just tells you the most bare in bones information. Okay, you got to figure out the protons, neutrons, and electrons from the facts that you know. So your Google Classroom assignment, finish your page 910 here, then complete the Google Classroom portion of the homework, and come to class, be ready to go over pages 11 through 13 in your atomic theory packet. Those of you who are doing them all on your own, it's inspirational. Thank you. And that's that. Thank you. Coming up next, isotopes, I think.